Welcome to the Deep Dive.
Hey there.
Today we're jumping into the latest buzz in AI. We've got some really interesting developments from around June 10th, 2025.
Yeah, it's a mix, some research, model performance, hardware news, big business stuff.
Exactly. The goal is basically to give you a quick handle on some of the most interesting things happening right now, cut through the noise a bit.
Yep, get you up to speed.
Okay, let's unpack this. And first up, something that really stirred the pot. This research paper from Apple.
Ah, yes, The Illusion of Reasoning. Quite the title.
Right. It seems to poke at some fundamental ideas about how LLMs actually, well, think or don't think.
Exactly. The researchers basically set up these classic logic puzzles for LLMs. Things like, the Tower of Hanoi, river crossing
That
problems.
kind of stuff that needs real step-by-step planning.
Precisely. And what they reported finding was, well, pretty significant.
Yeah. What did they say?
So first, the models seemed to hit a wall. They failed pretty consistently once the puzzles got beyond a certain complexity level.
Okay, that maybe isn't super surprising.
Maybe not on its own, but here's the kicker. Even when they explicitly gave the models the correct algorithm, the step-by-step instructions, they still often failed to generalize that reasoning, like change the puzzle slightly, and the algorithm didn't seem to help them apply the logic reliably.
So it's not just about knowing the steps.
Doesn't seem like it, based on their findings. And the weirdest part, they reported that as the tasks got harder, the models appeared to use less computational effort on the reasoning part.
Wait, less effort,
Mm-hmm.
not more. That seems backward.
Right. It's counterintuitive. The paper suggests it's like instead of digging in when the problem gets tough, they kind of shallow out, as if they're relying on pattern matching. And when the pattern gets too complex or unfamiliar, they just guess or give up internally.
Wow. Okay, so that definitely explains why it caused a stir.
Oh, yeah. The online debate was intense. Some people felt the paper was maybe reading too much into it,
How so?
Like saying these specific puzzles aren't really how we use LLMs anyway, or arguing, hey, a human would struggle with a massive Tower of Hanoi puzzle mentally too, that kind of thing.
Fair point. Were there other takes?
Yeah, there was definitely speculation about the timing. Coming out right before Apple's big developer conference, WWDC.
Ah, the strategic angle.
Some wondered if it was maybe laying groundwork. Like, if Apple's own AI approach isn't focused on massive scale reasoning, maybe this paper helps frame that by highlighting limitations in other approaches. Sort of a, see, that stuff isn't really working anyway vibe.
Interesting. Damage control, or maybe just justifying their own path.
Could be either. But then you had others saying, hold on, the core finding here is still really important.
Which part?
The fact that the models failed, even with the algorithm, that's a pretty direct critique. It suggests it's not just about needing more data to learn solution patterns.
Right. It points to maybe a deeper architectural issue, like how they process instructions.
Exactly. That was the argument. Something fundamental might be missing if they can't reliably apply logic they've been explicitly given.
So for you listening, this whole debate matters because it's really probing. What are these models actually doing? Is it genuine reasoning or just incredibly complex pattern matching?
Yeah.
Understanding these limits is key.
Yeah, it shapes everything from expectations to future research directions. We need to know where the boundaries are.
Okay, so while Apple's paper questioned the limits, other news showed models pushing practical boundaries. Let's talk coding.
Right, shifting gears to performance benchmarks. DeepSeek R1 0528 made quite a splash.
An open model, right? What did it achieve?
A really impressive score on the Aider Polyglot Coding benchmark. That's a test for fixing and completing code in different languages. It hit 71%.
71%. How does that compare?
Well, the big deal was the jump from its previous version, a huge 14.5 percentage point increase. That's a massive leap for one release.
Wow. Yeah, that's significant. Was there a comparison that stood out?
There was. An analysis showed that a quantized version, like a compressed, more efficient version of this DeepSeek model, specifically the IQ1M version, actually beat Claude Sonnet 4 when Claude was running in its basic no-think mode.
Beat Claude Sonnet 4?
Yep. DeepSeek got 57%, Claude got 56.4% in that specific mode. Now, gotta add the caveat from the source. Claude Sonnet 4, with its thinking mode enabled, did score higher, 61.3%.
Okay, got it. But still, DeepSeek, even compressed, is playing in the same league as a major commercial model on certain settings.
Exactly. And that leads to the real headline grabber, cost effectiveness.
Ah, the correctness per dollar.
Precisely. The analysis floating around suggested you could get something like 70% of that benchmark's tasks done correctly for under $5.
Under $5. That's really cheap for that level of coding help.
It absolutely is. It changes the game for developers or businesses using AI for coding. Suddenly, getting pretty high-quality assistance is way more affordable than using the big proprietary APIs for everything.
It makes you think that 14.5-point jump. Maybe they should have called it R2.
Huh. Yeah, that was definitely said in the community chats. People were like, any other company would have called that a major version bump.
Right.
It just shows how fast things are moving, especially in the open source space.
So the takeaway for you, if you're doing anything with AI and code, keep an eye on these open models like DeepSeek. They're becoming seriously powerful and can save you a lot of money. It's democratization in action.
Definitely. Okay, so from software performance, let's switch to the hardware underneath it all. News out of China about a different kind of AI chip.
The ternary chip, right. I saw that. We always hear binary zeros and ones. What's ternary?
So instead of just two states, 0 or 1, ternary uses 3 states to represent information. Think maybe -1, 0, and +1 or something similar.
3 states instead of 2. And they're using different materials too. Carbon-based.
That's what the reports mention, yeah. Carbon nanotubes or something similar, moving away from traditional silicon.
Okay, intriguing. But why? What's the advantage of 3 states?
The potential, the hope, is greater computational efficiency for certain AI jobs. If each computing element can hold more information or do a slightly more complex calculation because it has 3 states, you could potentially get more calculations done faster or use less power for the same work, especially for AI models that already use something called ternary quantization.
Like BitNet.
Exactly, like BitNet, where model weights are squeezed down to just 3 possible values. If your hardware natively understands those 3 values, you could see some real speed-ups.
A hardware-software match. Makes sense.
Yeah.
But surely it's not that simple. Our whole digital world runs on binary.
And that is the massive hurdle. Everyone pointed this out. All the software, the operating systems, the programming tools, the AI frameworks, they're all built on decades of binary logic.
So you can't just plug in a ternary chip and expect everything to work.
Not even close. You'd need a whole new software stack, or at least major rewrites, to actually use the hardware effectively.
Right. Building the chip is one thing. Making it usable is another.
And that's where the skepticism comes in. People were saying, cool idea, but how long until the software catches up? The integration challenge is just enormous.
So for you, the listener, this is a glimpse into really fundamental research. It's not just tweaking current tech, it's exploring entirely different ways to build the engines for AI.
But it also shows the flip side, how hard it is to change foundational technology once it's deeply embedded. It's a long game.
Okay, from fundamental hardware to fundamental business realities. OpenAI. Big numbers being reported.
Yeah, the headline was $10 billion in annual recurring revenue, ARR.
$10 billion, that's a lot of revenue. Doubled from the year before, apparently.
That's what the report suggested, yeah. Huge growth driven by things like ChatGPT subscriptions, their API usage, enterprise deals.
Seems like a massive success story, but there was a pretty big but, wasn't there?
A very big but. Despite that $10 billion revenue figure, the reports also said OpenAI is still losing a lot of money.
Still operating at a loss. How much?
The figure cited was around $5 billion in losses over the past year. And apparently that number doesn't even count the money they get from Microsoft through their partnership.
Wow. So revenue's rocketing up, but costs are still way higher.
That seems to be the situation. The interpretation is that they're playing the long game, focusing completely on growth, research, building bigger models, getting market share. Profitability isn't the main goal right now.
Pouring money back into R&D and that massive compute infrastructure they need.
Exactly. The scale is just staggering. Reports mention 500 million weekly users, over 3 million business customers.
And they have some crazy future targets too, right?
Yeah, an ambition to hit $125 billion ARR by 2029 was mentioned.
Okay, so this really highlights the economics of the AI race at the very top. It takes unbelievable amounts of investment.
It does. That $10 billion ARR is huge, but it doesn't mean they're rolling in profits. It shows the strategic bet on dominating the future, even if it costs billions now.
A high-stakes game.
Got it.
Now, shifting slightly, a comment from a big name in AI stirred things up again recently.
Right, Ilya Sutskever. He gave a speech, I think, at the University of Toronto.
Yeah, and one particular sentence seemed to grab everyone's attention.
The line was, "The day will come when AI will do all the things we can do."
Pretty direct. And pretty profound.
Definitely. And according to the reports, that single statement just reignited the whole conversation around AGI, artificial general intelligence.
Is it possible? When might it happen? What does it mean? All that.
All of that. It was just a reminder, really, that while we're focused on current models and their limitations, that ultimate grand vision is still very much driving a lot of the thinking and investment in the field.
Keeps the long-term goal in sight. Okay, and speaking of pushing capabilities,
Yeah.
what about making models work together?
Yeah, this is a really interesting area. The idea of model collaboration, there was talk about protocols like MCP, model collaboration protocol, and specific tools like a Gemini MCP server.
Okay, MCP. How does that work in practice? What's the
Alright.
concept?
The specific workflow discussed involved using different models for different parts of a task. For example, you might have Claude code to start things off.
Like do the initial analysis or drafting?
Exactly. Analyze the problem, make a plan, maybe write a first pass of the code.
Yeah.
Then you bring in another model like Gemini 2.5 Pro.
And what does Gemini do?
Gemini, especially using its huge 1 million token context window, would then review Claude's work, refine it, look for issues, maybe suggest improvements based on that wider context.
So it's like AI teamwork or peer review.
Kind of like having specialists. Claude is good at the initial coding. Gemini's strength might be the bigger picture, the architecture, spotting subtle connections, because it can see so much code at once.
Does it actually make a difference with the results?
Yeah, the reports mentioned measurable benefits. One specific example was a 26% speed increase in JSON parsing for a library after it was optimized using this collaborative approach.
26%, that's not trivial.
Not at all. And it lined up with what users were saying anecdotally, too. People found they got better results using, say, Gemini for the high-level design, and Claude for the detailed implementation and debugging.
The classic, two heads are better than one idea, but for AI.
Pretty much. The feeling was that a pair of models working together often outperformed a single model on complex stuff.
That really opens up possibilities, doesn't it? Maybe the future isn't just one giant supermodel.
It suggests maybe it's more about smart orchestration, building systems that leverage the unique strengths of multiple specialized models, like building an AI team.
Covering each other's weaknesses. Interesting.
Adds a whole new dimension.
Okay, so let's pull back for a second. We've covered quite a bit. Apple questioning reasoning limits.
DeepSeek showing huge practical leaps in coding.
China exploring entirely new ternary hardware.
OpenAI hitting massive revenue, but still investing heavily.
Ilya Sutskever reminding us of the AGI horizon.
And this idea of models collaborating, like with MCP.
It really paints a picture of a field just moving incredibly fast on all fronts at once, questioning foundations while simultaneously building skyscrapers.
Yeah, that's a good way to put it. You see this constant tension, right, between the deep research trying to understand what these things can and can't fundamentally do, like that Apple paper. And then the relentless push on the practical side, more performance, more efficiency, new ways of using them, like DeepSeek's cost effectiveness or the model collaboration idea.
It's definitely a dynamic time.
So here's something to maybe chew on, connecting those threads. If even our best individual models might have these fundamental reasoning gaps, as some research suggests,
Right.
how much could this idea of orchestrating multiple models change things? If you build a team of AIs, each may be good at different things, could that collaborative approach be the key to overcoming individual limitations and building truly robust, capable systems?
So is the path forward about the single genius AI or the perfectly coordinated AI team?
That seems like a central question emerging right now, something to think about.
Definitely something to think about. All right, that wraps up our deep dive for today. Thanks for joining us.
Yeah, thanks for listening.
We hope this gave you some useful insights into the whirlwind that is AI development right now. Keep digging, keep questioning. See you next time.